Alright, so I just bought this new drawing pad so that I could draw up on the YouTube and do little example problems. And I wanted to start with drawing tree diagrams for dependent probability situations, since that's something we've been working on. So our question here is, what is the probability that you select a red apple, then a green apple? And we're going to assume this is without replacement. So we have 3 red apples, 2 green apples. That's a total of 5 apples. A total, oh my goodness, my penmanship is atrocious. Total of, is that even? Oh my goodness, total of 5 apples. Cool. All right, pretend that says total. So we want to know, what is the probability that we select a red then a green? So I'm going to write down here, I'm going to say probability of P parentheses. Are you kidding me? P parentheses, red, then, oh, you're not doing this to me now. Red, then green. Okay. So I have the first 2 starting positions of our tree diagrams right here. So red is 3/5 because there are 3 red apples out of our total of 5. The probability of selecting red is 3 out of 5. Green, 2 out of 5 because there are 2 green apples out of our total of 5. If I selected a red apple, I'm assuming that I already took it out of the pot. So let's say the probability of selecting, oh, there we go. Did that D twice. Red a second time. Well, if I selected a red the first time and I took it out of the group, I would say, well, there are only 4 apples left, so that's my denominator. And if I took a red one out, that would leave 2 red apples out of my total of 4. The other possibility here is that we select a green apple. Oh my goodness. How does Sal Khan do this? Green apple, right? And there still would be only a total of 4 apples because we're assuming if I already chose red, right? If I already chose red, I'm taking that out completely out of the apples. So there was 5, but there would only be 4. But the number of green apples didn't change. So there would still be 2 green apples out of our total of 4. And then we look at these probabilities and we'd say 2/4 plus 2/4, that adds up to 1. So that makes sense right there. And while we don't exactly need it to solve this problem because we're asking if you chose red first, let's just fill out the other tree diagram. Our possibilities are, oh, there, yeah, let's just ignore the R there, right? Red, right? And our other possibility would be green. Oh my goodness. All right. I swear I'm going to get better at this as time goes on. Okay. So if we had selected a green apple first, which there was a 2 out of 5 chance that we did, we would pull that green apple out of the pot, just leaving 4 total, right? We're saying if we took this green one out, oh man, didn't even complete that 4. All right, if we had pulled that green one out first, it would be gone and there would only be 1 green one left out of the 4, and there would still be 3 red ones. Man, this is so messy. All right, so the probability of red then green, well, we want to say, well, what was the probability that we get red first, right? Probability that we get red first was 3/5. So we have 3/5. It kind of looks like a heart. Sort of beautiful. 3/5 times the probability that we then get green. Well, if we are then getting green, we want to start from when we started with red and then get green. We want to look at this probability, which is 2/4, or 2/4 is equivalent to 1/2, right? So I'm going to say 3/5 then is going to imply that we're using multiplication times 1/2. And when we do this, we get 3, our numerator times numerator is 3 over denominator times denominator gives us 10. So 3 over 10, which we might, what am I doing right here? Okay. Which we may also write as, or, oh my goodness, or 30%, right? So we might say that it's, how is it still attached there? Okay. Oh my goodness, pretend I'm, all right, there we go, 30%, or 3/10. So we might say that what is the probability we select a red apple and then a green apple? If we're talking about without replacement dependent probability, we would say 3/5 times 1/2. We'd say that's about a 30% chance or 30% likely